I'm going to start the homework video guide on question number 3 for section 6.1, and for this problem I need to label the system as consistent or inconsistent. Now consistent just means that there's an intersection point, and inconsistent means that there are no intersection points. So for question 3a, there's two lines, one in orange and one in green. Notice that the two lines don't intersect, so we call this an inconsistent situation here. So this is inconsistent because the lines don't intersect. Now let me just move on to letter C here. For letter C, here is one line in orange and here's one line in green. Because the graphs intersect at this point right here in black, that means we do have a solution. There is an intersection point, so we call this a consistent solution. Okay, so there's one intersection point. Now for letter B, what's happening for letter B is that you have one line here in green, and there is another line, you just can't really see it because it's actually on top of the green line. So if I highlight that in orange, the orange line is on top of the green line, so that the two lines are exactly the same. So there's actually many intersection points, right? There's many points on the line where the two equations intersect. So we call this a consistent solution because there's definitely more than one intersection point. Okay, so that's the definition of inconsistent and consistent. Consistent just means there's at least one intersection point, and inconsistent means that there are no intersection points. And you'll notice that for an inconsistent solution, generally that happens when the slopes are the same. But the starting points have to be different, right? So here's the y-intercept here, and here's the y-intercept over there. So if the y-intercepts are different, but if the slopes are the same, then that's always going to give you an inconsistent solution there. Okay, so knowing that, let's see if we can do question number 2 now. How many solutions will a system have if of linear equations if the lines have different slopes? Okay, so let's go ahead and try to illustrate this. You can probably figure this out by drawing a few different scenarios here. So here's a positive slope, and here's a negative slope. All right, so those are two different slopes. So what I see is there's one intersection point. So that means there is one intersection point, so one solution there. Okay, and you can also like draw different variations. You know, here's a positive slope, and here's another positive slope, and you still have one solution, right? So you can definitely play around with that, and you'll notice that you'll always have one solution. Okay. Let's move on to letter B. The lines have same slope but different y-intercept. Okay, so that's going to be 0 solutions. So this is the same thing as, so this letter right here, 2B, is the same thing as this situation right here, right? So we just talked about that, different y-intercepts, but the slopes are the same. So you'll notice that these two lines, the orange and the green line, will never intersect. So let's just say we have 0 solutions there. And for letter C, the lines have the same slope and same y-intercept. Okay, well, same y-intercept. Okay, so let's just put a y-intercept there, and here's my slope. Okay, and if I have another same y-intercept in green and same slope, then you'll notice that there's going to be infinitely many intersection points, right? So I'll draw that as a sideways 8, meaning there are infinite many solutions there. Okay, so that's some of the questions on the theory part of section 6.1. Now let's get into some of the questions where we use a little bit more algebra, a few more mechanics here, and let's see if we can get some of these questions done here. Determine whether the ordered pair is a solution to the linear system. Okay, so here's my ordered pair, 5, 2. All right, so that's my ordered pair, and I need to see if 5, 2 works for this linear system here. So I recommend that you label the 5 as an x. This is your x, and the 2 is your y. All right, so what you're going to do now is anytime you see an x and anytime you see a y, you're going to replace those with 5 and 2. All right, so if we do that over here, let's go ahead and do this. This will be 3, and we're not going to times by x, but we're going to times by 5, right? Because x has a value of 5. Plus, now what is the y value here? The y value is 2, right? So I'll put a 2 here, and that will equal to 17. Okay, so we're just replacing x and y with 5 and 2. So I'm not sure if that was very clear or not. So basically this 5 replaces that x, and this 2 replaces that y. Okay, let's go ahead and evaluate this. 3 times 5 is 15 plus 2. All right, on the left-hand side, I get 17, and on the right-hand side, I get 17. So that definitely works for the first equation. And now what we need to do now is we need to check if it works for the second equation there. So we have 2x plus 3y equals to 17. And once again, you're taking this x and that y, and you're replacing it with the 5 and the 2. All right, so this will be 2 times 5 plus 3 times 2. So I do apologize that there's so many colors around here. Maybe that will replace it. There you go. So hopefully you'll see that this guy is that guy right there. Okay, so let's go ahead and evaluate this. 2 times 5 is 10, and 3 times 2 is 6. And I have 16 on the left-hand side and 17 on the right-hand side. So clearly 16 does not equal 17. So although it works in the first equation, it does not work in the second equation. So your final answer is just a no. All right, so this question is more about just multiplying the numbers and adding up the sides. Okay, let's move on to letter C here. For letter C, I have an x over here and I have a y over there. So the idea is this 2 will replace that x. And this negative 4 this negative 4 will replace that y there. All right, so let's do that over here. So x will now be 2 plus 2 times. Now what's the value of y? That's negative 4, and that's going to equal to negative 2. All right, so let's work with that first equation there. This will be 2, and then 2 times negative 4 is negative 8, and that would equal to negative 2. 2 minus 8 is going to be negative 6, and this equals to negative 2 on the right-hand side. And notice that negative 6 does not equal to negative 2, so I can just stop and say that no, this is not a solution to the system of equations here. Okay, let's move on to letter G now. Letter G, let me circle the x and the y there, and what's happening is this 4 will replace that x, and this 6 will replace this y. Okay, let's go ahead and rewrite the first equation as 1/2. And the x now becomes a 4, and the y over here will now become a 6, and that will equal to a positive 4 on the right hand side. Okay, so let's do this. What is 4 divided by 2? Well, 4 divided by 2 is 2 plus, and what is 6 divided by 3? Well, 6 divided by 3 is 2, and 2 plus 2 is going to be 4, so 4 equals 4, the left hand side equals the right hand side, so that definitely works. All right, so now we got to try this on the second equation here. Just erase some of this. So let's take a look at the second equation here. Let me erase that. Okay, now I have, so basically this 4 now will replace that x, and this 6 will replace that y. Okay, let's go ahead and do the calculation over here. So I have a 1 over 4, and times by x, which is 4 in this case, plus 1/3. Times by y, which is 6, and then the right hand side equals to 3. Okay, so let's go ahead and do this now. 4 divided by 4. 4 divided by 4 is just 1, right? Plus, and what is 6 divided by 3? 6 divided by 3 is 2. And 1 plus 2 is 3. So 3 equals to 3, so it definitely works over here and definitely works over there. The left hand side equals to the right hand side, so I can say a yes over there. All right, so that's a very good exercise where you are calculating the expressions there and adding and collecting the terms there. All right, let's move on to question number 5 now. Okay, so match each system of linear equations with its solution. All right, so for this question, I recommend that you find the coordinates of the intersection point. So for the first graph, the intersection point is right here in blue, and ask yourself, what is that coordinate? So if I go right 4 and up 3, so this solution is 4, 3, right? And here's 4, 3 here, so that matches graph 1. Okay, and that's how you solve this particular problem in your homework. And for graph 2, here's my intersection point in orange there, and ask yourself, what is that point? Well, I go left 3 and up 4, so left 3 is negative 3 and up 4 is 4, right? So that's the coordinates of that point, and that matches, I guess that matches A, right? So this will be graph number 2. All right, let me just erase this. And then let's move on to graph 3. Here's my intersection point there in green, so that means I go left 3. So left 3 is negative 3 and up 1. So negative 3 comma 1, so that definitely matches graph C, so this will be graph 3. And that means this has to be graph 4. Okay, so that's how you would do question number 5 there. And the last thing we're going to do for the homework questions from 6.1 is we're just going to review some graphing concepts. Okay, let's go ahead and look at question 6a here. So I need to solve this by graphing, and when you're solving by graphing, you want to make sure that you're writing everything in the form y equals to mx plus b. Right, so we know b is your y-intercept, which is sometimes what I call the starting point in my class, and m here is your slope. All right, so that's going to be your rise over your run. All right, let's take a look at the first equation here, and let me just rewrite that over here. I'm going to rewrite it as 2x minus y equals to 3. Okay, so I want to make sure that the graph looks like the form in this orange box here, so I need to move things around. Here's a 2x. I'm going to move that to the other side. So if I move that to the other side, it's going to become negative 2x, and then this 3 will be just plus 3. All right, so that's step number 1. Negative y equals to negative 2x plus 3. And then I'm going to divide everything by a negative 1. And if I do that, what happens here is this negative sign in purple and that negative sign, they just cancel out, which gives you a positive y. And then over here on the right-hand side, these two minus signs, they become positive. So you have a 2x, and then you have a positive and negative. That gives you negative 3. So this is looking pretty good now. I like this because now it's in the form y equals to mx plus b. And this is where you would start. So negative 3. So on my graph, that's over here, 1, 2, 3. So that's your starting point there, negative 3. And then from there, I would take a look at your m value, which is 2. Now this is really 2 over 1, right? So when you're looking at 2 over 1, that means you're going up 2 and right 1. Right 1, right? So up 2 and right 1. So basically, you want to go up 2 and right 1. So over here, you're going up 2 and right 1, right? So up 2, so 1, 2, and over 1. And then you can see I'm always going up 2 and over 1. And just continue the pattern here, and then you got it. And then once you run out of space, just go down 2 and over 1. And that's how you graph the first equation there. And if you want, you can just put a straight line like that. Okay, that's the first graph. Let's go ahead and graph the second guy now. So let me just erase all this. Feel free to go back to the video if you need to see the steps again. So my plan now is I want to work on this part right here, x plus y equals to 3. So if I rearrange the terms here, this x here, I'm going to move that to the other side. And if I do that, I get y equals to, well, if I move the x over, it becomes negative x. And then this 3 just tags along as a plus 3. Okay, so y equals to negative x plus 3. This is looking pretty good because this is where you would start. So plus 3 would be about here, right there. So plus 3. And then one more thing that students need to recognize here is I have a negative coefficient there. So that's the same thing as like negative 1 over 1. And that means you go up 1. But because there's negative sign, you'd go left 1. Right, so up 1, left 1. So if I go up 1, left 1 here, so it's up 1, left 1 like that, right? So up 1, left 1, up 1, left 1. And then I go down 1, right 1, 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 down 1, right 1. And there you go, there's your graph right there. And as you can see, this purple dot right there, that's your answer. And that's the point 2, 1. And that's your answer right there. Okay, so once you get good at these graphing questions, you can probably move a lot faster. I'm kind of taking my steps really slowly here. So if you feel comfortable, go ahead and just move at your own pace here. I'll do one more question here, and then I'll stop the video and do the last few questions on a separate video. Let me start this question with the second equation on 6b here. F of x equals to negative 1/2 x plus 1. So remember, this is the same thing as y equals to negative 1 over 2x. Sorry, I'm just running out of space here. All right, so this is where you would start. Plus 1, so that there's my starting point, plus 1. And this part right here means you go up 1, but that means you would go left 2. Right, there's a negative leading coefficient, so that means you always go left. All right, so up 1, left 2. So that's, if I continue the pattern, that'll be like this: up 1, up over 2, up 1, left 2, up 1, left 2. And then if once I run out of space, I go down 1 over 2, down 1 over 2, down 1 over 2, and there's my line right there. Okay, so that's it for that second graph right there. And let's go ahead and look at the first graph, which is highlighted in yellow there. Okay, so if I work with this one here, I would recommend moving the x variable over to the other side. If you do that, let me just cover that up here. If I do that, I get 2y equals 2. Now remember, this x is positive, right? It's positive on the left-hand side. If I move it to the right-hand side, it becomes negative, and then this negative 4 just tags along like that. After that, you can divide both sides by 2. And the reason why you do that is to get the y variable by itself, so the 2's would cancel. Now, I recommend that this part right here, this negative and this 2 on the denominator, write that as negative 1 over 2. And then the x sign, and then negative 4 over 2 is going to be just negative 2. Okay. And remember, this negative 2 right here, that's your starting point. So negative 2 is right there. And remember, this part here in green, it's a negative leading coefficient, right? So that means you go up 1 and you would go left 2. Sorry, up 1 and left 2. So if I go up 1, left 2 there, that means I go up 1, left 2, up 1, left 2, up 1, left 2, down 1 over 2, down 1 over 2, down 1 over 2. And that's what you'd get there. And if I just draw the line connecting all of this, notice that the slopes are exactly the same, right? So same slope and different y-intercepts. The y-intercepts are different because one's at positive 1 and one's at negative 2, right? So different y-intercepts, so this means you have no solutions here. Oops, no solution. And that's it for that particular problem there. Okay, let's move on to letter C now. Now for letter C, let me attack the first equation first, because I can rewrite this as y would equal to 2x minus 4. And I will put the 2 over a 1 here so that slope is a little bit easier to identify. Now my slope here, sorry, my y-intercept is negative 4, so let's go down 4 spots. So there's my y-intercept. So that's your starting point, as I call it. And then let's take a look at your slope here, which is a 2 over 1. So that means we're going up 2, right 1. All right, so from that starting point here, we want to go up 2 units and 1 to the right. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then once we're out of space, I can go down 2 and left 1. All right, and that right there is that's how I would graph the first equation there. Okay, let's go ahead now and let's take a look at the second equation, which is highlighted in yellow here. This is the equation that we're going to do a little bit of work here. So let me copy out the negative 1/2 y. Now here's a positive x, right? If I move that to the other side of the equation, that would now make the x negative, right? So a positive term will become negative if you bring it over, so it'll be negative x. And then this 2 would be just plus 2. Okay, that's step number 1. And let's go ahead and deal with this 2 on the bottom, right? So how do you deal with a 2 on the denominator? Well, that means you want to multiply everything by 2. So multiply that by 2 and multiply that by 2. If you do that, I get negative 2x. And then 2 times 2 will be 4. And then on the left-hand side, I'm left with that negative 1 and then the y. Right? So that's how you can get rid of the denominator, by multiplying both sides of the equation by 2. And then from here, I just recommend that you divide each term by negative 1. And you'll notice that this negative 1 and that negative 1 there, they will cancel off, giving you just a single y. And then I have a negative and a negative. That will make it positive, so positive 2x. And then we have a positive and negative there, so that would make it negative, so negative 4. And just to kind of make things clear, I'll put this 2 over 1. Okay, so let's go ahead and graph this. This right here means this is where you start at negative 4. So negative 4 is right there, so let's put a purple dot there. And you'll notice with this question, the slope here, which is 2 over 1, that means you go up 2 and right 1. So up 2 over 1, up 2 over 1. And if I go up 2 over 1 from that purple dot, so up 2 units and right 1, you'll notice that I get the same dots as before, which means, you know, that basically it's exactly the same equation. And that means we have infinitely many solutions because when you have two graphs that are exactly the same, they intersect everywhere. So we'll say there's infinite solutions here. And this sideways 8 means infinite. Good. Okay, I think we just have two more graphs to go, and then we're done this homework video guide. Let's go ahead and do the last ones. I think it was K and L. I like K because you don't have to do any algebra. It's pretty much all done for you here. So let's go ahead and just graph these. I have a -1 here, so that means you go down 1. And then I have -1 over 3. -1 over 3, so that means you go up 1, left 3, right? So up 1, left 3. So up 1, left 3. Whoops, I did that wrong. Make sure I count this correctly. So up 1, left 3, right? So up 1, left 3, and up 1, left 3. And then you would go down 1 over 3 and down 1 over 3. And that's it, you're done. For the second graph, g of x here, this is my y-intercept, which is -6. So let's go ahead and find that. -6 is somewhere down here. That's 2, 3, 4, 5, 6. So this is -6 right there in blue. And then from that point there, my slope here is 4 over 3. So this just means you're going up 4. Remember, we always go up first, and if it's positive, then you go right. So up 4 and left 3. So up 4 and left 3. So let's do that. Up 4. So 1, 2, 3, 4, and over 3. 1, 2, 3 right here. So there you go. And then up 4, 1, 2, 3, 4, and over 3. 1, 2, 3. And there you go. And there's the line from my previous one. And you'll notice that this is my intersection point right there. And that's the point 3, -2. So 3, -2 is, sorry, it would be, it'd be 3, 3, -2 there. Okay, great. And we have one last question to do, and then we're done this homework video guide. This one's probably the easiest one here. X equals to 2. So here's 1, 2, and then you just draw a vertical line. And then you have y equals to -3. So 1, 2, -3, and you draw a horizontal line. And there's my solution right there, which is the point 2, -3. All right, so that concludes this homework video guide.